So as you can see on the screen, I've gone ahead and filled in almost all of the values that should have worked for numbers 1 and 2. So if you already checked your answers on the answer key, this might be a bit redundant, but either way, this gives you access to that. And hopefully now you've seen a pattern, something that made you realize you didn't really have to do every one of these with a calculator. You could have kind of said to yourself, hey, wait a minute, I think I see what's going on here. For instance, it wasn't a coincidence in number 1 that log 5 and log 6 together added up to the same thing as log of 30. And in the next one, natural log 5 and natural log 2 adds up to the same thing together as you'd get from doing natural log 10. Specifically, it's what's going on with those numbers, the numbers inside the logs, that was not a coincidence. We know that 5 and 6 are both factors of 30. Specifically, 5 times 6 is 30. And we know that the same pattern works for 5 and 2, which multiplies together to be 10. We know that 5 times 5 is 25. And it seems that every combination of numbers here has the exact same relationship. But the number you ended up finding by guess and check really just was the product of the two individual numbers in each of the separate logs. So in general, if you wanted to summarize this, we would say that log of A plus log of B is equal to log of the product A times B. Because that is a product where you're multiplying A and B, we call that the product property of logs. So in that space down below where it says product property of logs, we can even include this little abstract statement as a definition, that the log specifically of any base. So you can just write base here to show that any subscript with any base will work. So log of any base with a singular value A plus a log of the same base with any singular value B is equal to a log, again with the same base, of the product A times B. Now, it is worth noting here that the logs all do need to be compatible. They all need to have the same base throughout the problem. They need to be like terms, so to speak. So for example, in this first example, log was base 10, log was base 10, log was base 10. Natural log was base E. In the second example, natural log of base E, natural log base E. It actually doesn't matter what the base is. So notice here, this was a base 10 problem in the first example. The second one was a base E example, and yet they both hold the power property, or the product property. They both totally work. It's just a matter of being consistent. You won't see a problem that says natural log 5 plus regular log 2. That would be like a mix and match that isn't really allowed. They're not like terms. So one thing to notice in all of the problems that you're going to do, the bases can be anything as long as they're consistent. So like down here, for example, in some of these problems you'll see here, log base 6 of 9 plus log base 6 of 2, that's an example of something that's going to work. Because log base 6, those are both compatible. The 6's don't end up doing anything. Interestingly enough, what you hopefully noticed is that it's the numbers after the log base that dictate your product. So it's not the base in the problem, it's the actual number that is part of the log. That's the part that does the product. So hopefully you notice that. And you can do any examples here. The product property totally works. I'll just list a couple of examples that are kind of easy. Say like log base 7 of 4 plus log base 7 of 10. I just picked two random numbers. Notice a couple of things. Both of my logs are log base 7s. It doesn't matter that they're log base 7s. Notice when I write equals, it's still going to be log base 7. But we're going to multiply the 4 times the 10. That's the product bit. And we'll call it a log base 7 of 40. So the base 7 is just consistent all the way through, and it's the numbers themselves that are going to multiply. The other thing worth noticing here is that the product property is indicated with this plus sign. The plus sign between the two individual log statements is the kicker in the product property. So that's something a little bit noteworthy, because even though the product refers to what's happening inside of each log, the numbers themselves, or the logs themselves, are being added. So the first log is adding to the second log. And that's something that we'll get used to, but worth noting again. The product property is actually linked to this plus sign. So pay attention to that. Now you can also use the product property a little bit backwards. We could say that log base, and again I'll just make up one, log base 3 of 12 plus something unknown would be equal to log base 3 of, let's say, and I'm just making up an example here, 60. You could work backwards. You could say to yourself, okay, well wait, something needed to multiply with the 12 to give me 60 as an answer. So you can always work backwards and ask yourself, well, what could that have been? 12 times what would be 60? So we can predict that that missing term must have been log base 3, because we know it had to be consistent with the other log bases. And then you'd ask yourself, well, 12 times what is 60? Oh, well, that would have to be 5. So we know what's missing. So the product property has lots of flexibility, but generally the point still stands. If you have two logs being added together, you would multiply their contents, so multiply what's inside of the logs, and join it together into one single log. We call this the process of condensing. We're taking two separate logs with smaller pieces and condensing them down into one single log with a bigger value. So that's called condensing. Now, hopefully you picked up on the idea that this was not the only property at play when it comes to logs. There's another property at play in question number 2, and it's very similar. In question number 2, it was not a coincidence that natural log 20 and natural log of 5 ended up working together in their example to give you natural log of 4. The question is, why? The answer is because we were using a division pattern. Hopefully you picked up on that, that 20 divided by 5 is 4. And in the next example, 30 divided by 3 is 10. 5 divided by 2 is 2.5. 27 divided by 9 is 3. Then you got a kind of unpleasant one. 375 divided by 17 was not a nice number, but it totally works. And then hopefully we can say to ourselves, okay, another pattern here. This was a division pattern. And the major difference, the reason why we knew it had to be different from number 1, was because the logs themselves were subtracting. So if you naturally were thinking about subtracting as being the opposite of number 1's adding, that was wise. Because if your brain switched gears to opposites and you went, well, number 1 I'm multiplying, and if question number 2 is the opposite, I must be dividing, that was an excellent instinct to tap into. So if you did the more abstract version of things, in the last part of question number 2, you probably realized that natural log of b minus natural log of a means that we are dividing those two separate pieces, and we would call it the natural log of b divided by a. I write those things as fractions. You can write divided by with the old school division sign, whatever you want, but that is called the quotient property. Quotient is just a fancy word for divide. So the formal definition of the quotient property looks a lot like the formal definition of the product property, but with just a couple of small cosmetic differences. First, it does work for a log of any base. You could see that here. Logs, natural logs, different bases, and yet it still worked the same. So the log of any base of, we'll just go with b again, minus a log of the same consistent base of some other value a is equal to merging them together or condensing them together into one single log expression with a consistent base and dividing whatever b and a are. In that order. It's important to note that when you're dividing, order matters. B divided by A is a different result than A divided by B. You've seen that. And it's related to the fact that this is a subtraction relationship. If you're subtracting things, order matters. And if you're dividing things, order matters. So it kind of makes sense that those two skills go together in a complementary property, because those are the two skills in which order matters. In the product property, order doesn't matter. A times B is the same as B times A. A plus B is the same as B plus A. It wouldn't matter if you switched them around, but with subtracting, it matters a lot. So again, here are some examples just to make sure that you've kind of seen the properties here. Let's say I had log base 9 of 21 minus log base 9 of 7. You could say very quickly, hey, yeah, those are similar logs, similar bases, and they're subtracting, so I can use the quotient property. Log base 9 would stay consistent of 21 divided by 7 is 3. How do you know you're dividing? Because of the subtraction sign. So long story short, if you see a plus sign, that tells you you're going to multiply A and B. And if you see a subtraction sign, that tells you you're going to divide the B and the A. So again, you can use this as a little bit of logic. What if you had something you didn't know? Minus log base 4 of 2, and you had an answer of log base 4 of, say, 10. And you could ask yourself, well, what was that something? What was I starting with? I see a subtraction sign, so I must have been dividing. Something divided by 2 gave me 10. As a result, what could that original thing have been? Oh, well, log base 4 of, that original thing must have been 20, because 20 divided by 2 is 10. So hopefully that flexibility makes sense. Hopefully the basic ideas of adding and subtracting versus multiplying and dividing makes sense, because the idea is basically to focus on product as the result of an addition of two logs. So product is always intrinsically linked with the word addition, and quotient as the result of subtracting two logs. Remember, quotient is linked to the word subtraction, which might seem counterintuitive if you're like, wait, no, product means multiply, quotient means divide. That's true. But when it comes to logs, you will see a plus or a minus sign as the signal to multiply or divide. You won't see a multiplication or division sign, which sounds strange at first, but hopefully you'll get used to it. Now that you've seen this though, try to take some time to do question number 3. Because in question number 3, they're going to prompt you to think about these properties and to fill in the missing blanks, much as we did in these examples here. For example, over here at the beginning it says log base 3 of 60. So every pair of numbers that we want to make has to give us a 60 as a result. So let's think about this first example, log base 3 of 6 plus something missing. Well, we know it's going to have to be a log base 3 because it has to be consistent with the other parts. So then I'm asking myself, okay, if it's a product, it says product, and I can see the little plus sign, so I know they want me to use the product. The question is, 6 times what would give me 60? Well, I know that 6 times 10 would work, so that must be a missing blank of log base 3 of 10. So again, it's not that the numbers are tricky to find, we just have to pick up on that context. Same thing with the other one, log base 3 of 3 plus something. Well, we know it's going to have to be a log base 3 again, because it has to be consistent. 3 times something has to take us back to 60. Well, that must be 3 times 20, so we know what's in the missing space. The next part switches to a quotient. I can tell because it says quotient property, and because now I see a minus sign in the original partnership. So log base 3 of 120 minus something. Well, again, I know it's going to be log base 3 of something. Now I think of dividing. 120 divided by something is going to have to take us back to 60. 120 divided by 2 is going to work. So notice we still write the log base 3, but it's the number in the log that is really coming from that quotient. Same thing goes with the last one, 240 divided by something. We know it's going to have to be a log base 3 preceding it, but 240 divided by something is going to have to give us 60. Well, we know that has to be 4. Now for the rest of the problems, you're going to kind of use your detective skills a little bit to help you figure out what's going to work. For the most part, there are lots of different combinations that you can try, especially in these next rows, where they're not really dictating what one term or the other has to be. All we know in this first example in the second row is that you're going to use the multiplication property, the product property, and the numbers that you choose are going to have to multiply to 36. But you have tons of options. You can do 36 times 1, 9 times 4, 6 times 6, 2 times 18. Tons of different choices there. So you can write anything that you want to as long as you're consistent, as long as you're using the correct property, either multiplication or division, and as long as you're choosing numbers that are compatible, meaning numbers that really do multiply to 36 or divide to 36, depending on which property you're trying to use. So try question number 3, see if you can get the hang of the product and quotient properties, and then in the next video we'll talk about what types of problems these product and quotient properties would appear in.